So, welcome to Chapter 6. We did a little bit from Chapter 6. We talked about different kinds of polygons and hexagons, nonagons, octagons, and then we talked about how and we were especially talking about quadrilaterals. Chapter 6 is about quadrilaterals, and the basic thing we learned about quadrilaterals so far is that their angles add up to, if a triangle's angles add up to 180, then a quadrilateral's angles add up to 360. And that was basically all we learned so far in section 6.1. And what I'm learning so far right at this minute is that there's a huge delay when I actually put my stylus on the screen and when the thing appears, and it makes my handwriting worse. But chapter 6 is about quadrilaterals. Okay, so in the getting ready for chapter 6 section, you guys were told to sort of directed towards these pages. So you were asked to remember ways to prove triangles are congruent. You can prove them by showing, oh look, all their three sides are congruent, so I know they're congruent. Because the three sides are congruent, I know the three angles are congruent. Or because two sides and the included angle between them are congruent, the triangles are congruent. That means the third side has to be congruent, the other two angles. So again, these are shortcuts. When you have a pair of triangles, there's two more shortcuts. If I know two sides and the included angle, or two angles and the included side, or if I know two angles and the not included side. If I know two angles and any one side, it doesn't matter. If I know two angles and one side, I'm good. I can prove congruence. And that's where we're going with this. Now, they also direct you to remember what happens if you have a transversal going through two parallel lines. If you have a transversal going through two parallel lines, the corresponding angles will be congruent. The alternate interior angles will be congruent. So interior means inside the parallel lines. But they've got to be on opposite sides, alternate sides, to be congruent. If they're on the same side, they're called consecutive interior, and they are supplementary. Not congruent, but supplementary. And if they're alternate exterior, they are congruent. And a perpendicular transversal just makes a bunch of 90-degree angles. Okay, all that is useful to you because it helps explain this. These are the new rules that you learn. They're on page 330, and they tell us everything we need to know about parallelograms. And in case you can't read them, here's what they say. First, let's remember what a parallelogram is. In a parallelogram, it's a quadrilateral, and opposite sides are parallel, both pairs. Both pairs of opposite sides are parallel. So if both sides of opposite sides are parallel, if it's a parallelogram, then this one says, this here says opposite sides are congruent also. So not only are opposite sides parallel, but they're also congruent. This here says that opposite angles are congruent. And when it says opposite angles, it means like diagonally opposite. Like here in this example, Q and S are congruent. Q and P are not congruent. Q and P are not opposite. They're called adjacent. Adjacent means next to. So adjacent angles, well, there's a rule for those too, and that's down here. Adjacent angles, like P and Q or P and S, are supplementary. And then this last one is the most complicated one. I'm not sure if we'll be discussing, well, I'm sure we will discuss it. It says that the diagonals cut each other in half. So if you make the diagonals of a parallelogram, where they cross, that crossing point becomes the midpoint of each of them. Now it's not true if it's a non-parallelogram. If it's like a trapezoid, it won't be true. But so those are the four rules, basically, of a 4 special rules of a parallelogram. Okay, and let's see what we can do with those. All right, FGHJ is a parallelogram. Find the unknown length and explain your reasoning. All right, so JH is the bottom side. What do we know? Well, it's parallel to FG up here. That's its opposite side, and opposite sides of a parallelogram are congruent. So right here, therefore, JH is 5 because opposite sides are congruent. If it's a parallelogram, only if it's a parallelogram, that's given in the problem. It is a parallelogram. Okay, what about JK? JK is a diagonal, and it's this segment right here. So, what do you guys think JK is? Well, looks like KG is given as 3, and what do we know about K? Well, it's the point where the 2 diagonals meet. And when the 2 diagonals meet, that point K will be the midpoint of each diagonal. So that means if KG is 3, then JK also has to be 3. Because diagonals don't ever have handwriting like that. Bisect each other. The way you spell diagonals is D-I-A-G-O-N-A-L-S. Okay, next example. PQRS is a parallelogram. Find the angle measure, angle R. So this is where we get into what's opposite and what's adjacent. So is angle R, because opposite angles are congruent, adjacent angles are supplementary. Congruent means the same. Supplementary means adds to 180. So do P and R look more like they are the same or they add to 180? Think of it this way. You'll know if they're supplementary because one will be acute and one is obtuse, right? If you have one acute, one obtuse, and you know they follow one of the rules that we're talking about, then they're probably supplementary. In this case, P and R, they both look acute. Therefore, they're congruent. And so R, the measure of R is 70 degrees. Measure of R is 70 degrees. And how about Q? Well, how about Q? If you said Q is got to be supplementary, you're correct, because Q is adjacent next to R, and it's next to P. It's next to both of them. And because it's adjacent, that means it's supplementary. You can tell it's obtuse. So one's obtuse, one's acute. They must add up to 180. So 180 minus 70 is 110. And so therefore, the measure of Q has got to be 110 degrees. All right, this one says, we've got a parallelogram, find X. Well, they gave us, you can see the beginning of the solution down here. They gave us 2 angles, and a wrong way, do not say, oh, 3x equals 120. Why not? Because they're not opposite. They're not equal. One's acute, one's obtuse. They're not equal. What are they then? If they're not, if we know a rule applies, but it's not the equal rule, it's the supplementary rule. What's supplementary mean? Adds to 180. So 3x plus 120 equals 180. And now we solve from there. Now I always want to get one x term on one side and a number on the other side. So then I can just divide simply, divide by 3, divide by 3. 3 goes into 6 2 times, add a 0. X is 20. Okay, last problem. A drafting table is made so that the legs can be joined different ways to change the slope of the drawing surface. In the arrangement below, the legs AC and BD do not bisect each other. Is ABCD a parallelogram? You know, kind of want to leave that. I wish you were here so you could tell me. I feel like you guys would all tell me right away whether this is a parallelogram or not. But AC and BD are what's of the parallelogram? If you said, or of the quadrilateral, I don't know if it's a parallelogram. AC and BD are diagonals. And if it was a parallelogram, they would bisect each other. Here it says they do not bisect each other. Therefore, it's not a parallelogram. And maybe you could tell me another reason why it's a parallelogram in class tomorrow. Excuse me, why it's not a parallelogram. Maybe you could tell me another reason it's not a parallelogram in class tomorrow.